Everything around us, from the smallest grain of sand to the largest star, is made up of tiny particles called atoms. These atoms are the fundamental building blocks of all matter, forming the very essence of everything we see and touch. For a long time, scientists thought atoms were the smallest things in the universe. They believed that these indivisible units were the ultimate constituents of matter. Then they discovered that atoms are made of even tinier particles, which we call subatomic particles. This revelation opened up a whole new realm of scientific exploration and understanding. These particles, like electrons, protons, and neutrons, are the building blocks of the universe. Each of these subatomic particles plays a crucial role in the structure and behavior of atoms. The world of these subatomic particles is extremely strange and doesn't follow the rules of classical physics, which governs the world we see every day. Instead, it operates under the principles of quantum mechanics. In the quantum world, things aren't so clear-cut. The behavior of particles is governed by probabilities rather than certainties, leading to a realm of unpredictability and wonder. For example, particles can be in multiple places at once and can behave like both particles and waves. This dual nature challenges our traditional understanding of physics. This area of science, which studies the bizarre behavior of particles at the smallest scales, is called quantum mechanics. It is a field that continues to intrigue and puzzle scientists, offering endless possibilities for discovery and innovation. One of the most mind-boggling concepts in quantum mechanics is wave-particle duality. This principle challenges our conventional understanding of the physical world. It suggests that every particle in the universe, whether it's an electron or a photon, light particle, can act like both a particle and a wave. This duality is fundamental to the nature of matter and energy. Imagine a beam of light. We often think of light as a wave, traveling through space and creating beautiful patterns. We know it travels in waves, creating those characteristic patterns of light and dark areas. These patterns are a result of light's wave-like behavior. But light also comes in discrete packets of energy called photons, which act like particles. These photons can be counted and measured individually. It's like a coin that can be both heads and tails simultaneously. This analogy helps us grasp the strange nature of quantum objects. How can something be two different things at once? This question has puzzled scientists for decades. That's the mystery of quantum mechanics. It defies our everyday experiences and forces us to rethink our understanding of reality. It's like trying to fit a square peg in a round hole. Our everyday intuition just doesn't cut it in the quantum realm. The quantum world operates on principles that are fundamentally different from the macroscopic world we live in. Another weird thing about the quantum world is Heisenberg's uncertainty principle. This principle is one of the cornerstones of quantum mechanics and has profound implications for how we understand the universe at the smallest scales. This principle, named after physicist Werner Heisenberg, states that we can never know both the exact position and momentum of a particle at the same time. In other words, the more precisely we know one of these values, the less precisely we can know the other. It's not a matter of our instruments being not precise enough. It's a fundamental limit imposed by the laws of nature. This inherent fuzziness is not due to technological limitations, but is a built-in feature of the quantum world. Imagine trying to catch a fly buzzing around a room. The fly's erratic movements make it difficult to predict both its exact location and speed at any given moment. If you use a net, you might know its location at the moment you trap it, but you won't know how fast it was going. The act of trapping it changes its behavior. If you use a radar gun, you could know its speed, but not its exact position. This analogy helps illustrate the core idea of the uncertainty principle. In the quantum world, it's like the act of observing a particle affects its behavior, making it impossible to know everything about it with perfect certainty. This interplay between observation and reality is what makes the quantum realm so fascinating and mysterious. Section 4. Quantum mechanics in action. Quantum mechanics may seem like a strange and abstract theory, but it has had a profound impact on our understanding of the universe and has led to some life-changing technologies. For instance, lasers, transistors, the building blocks of computers and smartphones, and magnetic resonance imaging, or MRI, all rely on the principles of quantum mechanics. These technologies have revolutionized various fields, from medicine and communication to entertainment. And we've only just begun to scratch the surface of what's possible with quantum mechanics. Section 5. The uncharted territory of quantum mechanics. Quantum mechanics is a relatively new field of study, and scientists are still trying to unravel its mysteries. The more we learn about the quantum world, the more questions arise. Can we build quantum computers that are exponentially faster than today's computers? Can we harness the power of quantum entanglement for teleportation or instantaneous communication? The possibilities are truly endless. As we venture deeper into the quantum realm, we can expect even more groundbreaking discoveries that will reshape our understanding of the universe and lead to technologies we can only dream of today. The future of quantum mechanics is as bright and as limitless as the universe itself.